Hi guys, in this video we'll be looking at cross-elasticity of demand, XED of substitutes, XED of complements, XED of unrelated goods, and then we'll be finishing off with a summary.
So let's start talking about cross-elasticity of demand, and we'll jump straight into an example, talking about ice lollies and ice creams. Now, the first thing that we can talk about with reference to ice cream and ice lollies is that these two are substitutable goods. If you go to an ice cream van, you're probably not going to get both an ice lolly and an ice cream at the same time. They're substitutes. So what we might observe is if the price of ice lollies increases, more people will buy a substitute good such as ice creams. So the price of ice lollies are increasing relative to the price of ice creams. And it turns out in response to this, we end up demanding more ice cream because ice lollies are now relatively more expensive compared to ice cream. Therefore, we can see that the price of ice lollies and the demand for ice creams is linked. And we have already seen that elasticity is the responsiveness of one variable to a change of another variable. So what are our variables in this case when we're talking about two different goods? And this is where we talk about cross-elasticity of demand, otherwise known as XED. And XED is the responsiveness of demand for good B to a change in the price of good A. So the price of one good is changing, and that's affecting the demand for another good. So in this case, when we're talking about the ice cream and ice lollies, it was the price of the ice lollies that was changing, and that's essentially good A. And then that's affecting the demand for good B, our ice cream. What's this going to look like in an equation? And it's going to look pretty similar to our previous equations for elasticities. And it's going to be the percentage change, and remember that delta sign means change, the percentage change demand for good B divided by the percentage change price of good A. So again, it's going to be the quantity over the price. And in this case, we're looking at two different things. So a good way to remember this is always Q before P. But when we're talking about cross-elasticity, we want to be having different goods in our equation. So when we're observing the price change of one good, we want to have the quantity change of the other good. So let's try use a numerical example to show what we're talking about to calculate XED. So XED is equal to the percentage change of quantity of good B, I'll do GB for good B, divided by the percentage change price of good A. And let's substitute our numbers in. If the percentage increase in demand for good B is 80%, therefore at the top we have 80%, as the percentage increase in the price of good A is 160%. And this gives us our conclusion that our XED is 0.5. Let's use an example using raw numbers this time. So the demand for apples increases from 3 units to 6 units as the price of strawberries increases from £1 to £2. Let's calculate the XED of this. So our first step is writing down the equation for the XED, which is percentage change in demand for good B over the percentage change of price for good A. And in this case, our good A is going to be strawberries and our good B is going to be apples, because good B is about quantity and good A is about price. Now we write down our equation for percentage change, which should be quite familiar now. New figure minus the old figure, all divided by the old figure, all multiplied by 100. Okay, so now let's do the percentage change of quantity of apples demanded. Now we have our new figure, which is 6, minus the old figure, which is 3, all divided by 3 times by 100. And that's going to be equal to 3 over 3 times 100. So it is 100%. Now let's do the percentage change in the price of strawberries. So our new price is £2, and we're going to minus that by £1, all divided by the old price of £1 times by 100, which is going to be equal to £1 over £1 times 100. So our final percentage change in price is 100%. So now let's put this into our XED. So it's percentage change in quantity of good B, the apples, and the over the percentage change in the price of good A, the strawberries. And what we've seen is percentage change in quantity of good B is 100, and the percentage change in price is 100% as well. Therefore, our XED value is equal to 1. Okay? So again, these numbers have a real meaning towards something. So XED allows us to understand how the demand for a good changes due to a change in the price of another good. And this is our equation again, percentage change demand for good B divided by the percentage change of price of good A. When we think about goods that are in competitive demand, these kinds of goods are called substitutes. So I want to imagine that the price of brown bread increases, but the price of white bread stays the same. So it's imagining that this is our price for brown bread and it increases all of a sudden to being a lot higher, whilst the price of white bread is staying fixed. We now think that because they are substitutes, people will switch from brown bread to white bread, and so demand for white bread will increase. So here the price of brown bread has gone up and the quantity of white bread has gone up as well. Therefore, an increase in the price of brown bread leads to an increase in the demand for white bread. These two variables of price for one good and demand for a substitute good therefore move in the same direction. What do we mean by moving in the same direction? Well, the price increases, and when we say same direction, we mean that something is increasing as well, and that's exactly what we have observed. The price of one good has increased, and therefore the substitute good has increased in the demand quantity too. Hence we say they're moving in the same direction. And this explains why an XED curve will be upward sloping for substitute goods. Because as the price of the brown bread is increased, we are demanding more white bread. And therefore we could expect a positive number for XED. If they're both increasing, then that means they're both positive numbers. Therefore, XED for substitutes is a positive number. On the other hand, there are goods which are consumed together, and these kinds of goods are known as complements. So imagine that the prices of printers has increased. It used to be really low, however, now it's going to be really high as a result of some kind of movement in the market, and this is going to affect a complementary good for a printer. So if fewer printers were to be demanded due to the higher price, this means that the complementary good of printer paper would also be demanded less as well. Because if we're demanding less printers, then we are necessarily buying less paper to put in those printers. There's no use in having excess paper when you have less printers. Therefore, an increase in the price of printers leads to a decrease in demand for printer paper. So in our equation, the bottom number, which is the price change of a good, that's going to be positive, but then our numerator, the top number, that's going to be negative as the demand for the other good, the complementary good, has fallen. And that's why we say that these goods are moving in opposite directions when we're talking about complementary goods. The price has gone up, however, the quantity in itself has gone down. And it's because they move in opposite directions that we're able to explain that there is a downward sloping XED curve when we are talking about complementary goods. So if we're seeing that the price of printers is increasing, as we can see here, then less paper will be demanded. Hence we would say XED is negative when it comes to complementary goods, because the percentage change in quantity is negative. We're buying less as a result of an increase in the price of another complementary good. So what about goods that are completely unrelated? Let's imagine strawberries. The price of strawberries has increased dramatically, again, because of some movement in the market. And let's say that we're thinking about teddy bears here and thinking about how the price of strawberries affects teddy bears. In reality, we know that there is no link between teddy bears and strawberries, so there's no impact on the demand for teddy bears. Therefore, these two unrelated goods will have an XED value of 0, and that's because, again, the equation says that it's the quantity over the price, and the price has increased, so that's an actual real number, but the quantity demanded is still 0 because the change in the price of strawberries hasn't affected our decision to buy teddy bears.
Hey guys, I hope you enjoyed the video, and if you're looking for an amazing A-level economics resource, join me today in my series of engaging bite-sized video tutorials. Just click the SnapRevise smiley face and together let's make A-level economics a walk in the park.